Is it recording? I don't think it's doing it. All right. So, translations. Slide. Translations is part of this whole big topic called transformations. When you hear transform, what do you think? Transform. Transform. I think of Optimus Prime. Transformers. Right? Nobody else? Am I just the only guy that likes that movie? So in Transformers, right? Optimus Prime starts off as what? A semi-truck. That's before the transformation. After he transforms, what does he become? A robot. So he goes, starting at a tractor trailer, he transforms into Optimus Prime. So we're going to look at one specific transformation today. That transformation is called a translation. Okay? A translation is a transformation that maps all the points of a figure the same distance in the same direction. So, when you have a translation, aka a slide, everything moves the same distance in the same direction.
Are you there?
Hello. I do. Yes, ma'am. Ashley, attendance office, picking pass. So, how are you supposed to know how to slide, how to move? Right? When I say 2 plus 2, what are you doing? Adding. Why are you adding? Because I said plus, right? So how are you going to see and know translate? There's called this thing that's the translation notation. Has anybody ever seen it before? Yes, you have. Looks like this. What do you think the T stands for? Translate. It will give you instructions. That's it. That's translation notation. It says translate. What do you think this number means? Left and right or up and down? When you plot points, which direction do you go first? You go X direction first. So the first number is your left and right directions. It says +1. That's 1 to the right. Okay? The second number is your up and down or your Y direction. This is your up and down. So if I was going to translate according to these directions, what would I do? Right 1 and up 2. So you take whatever point you have, you go right 1 box, and then you go up 2 boxes. Great, right? I'm asking you guys to count today. There should be absolutely no mathematical operations. I'm asking you to count boxes. 1, 2, 3. Okay, that is one form. That's called vector notation. That's in chemistry or physics. Anybody taking those classes? Physics? Anybody physics? So vector notation. There's also the mathematical notation. It looks like this. This is called translation notation. This is called vector notation. Which one do you like better? I like this one better. It's easier to read. This one literally reads the coordinates x, y map to x plus 1, comma y plus 2. That makes a lot of sense, right? I like this one. So I'll use this one pretty much all day today, the vector notation. So the biggest mistake you guys might make is go up when you should go left or go down when you should go right. So just make sure you're following directions. Is there any way that I can make it from here to that bookshelf back there in a straight line? No, there's not. What's in the way?
This.
All the desks are in the way. So I literally have to translate myself in the X direction first. That's like plus 17 steps. Then once I can find a clear path, I go, and I've reached my destination. That's stupid, right? But math is stupid to you guys. So that's why we do that. You have to go, you can't run through buildings. You're not Optimus Prime. You guys have to follow the streets. So let's try it. Let's see what happens. I want you guys to see if you can write the rule to go from the first shape to the second shape. Hold on. Well, which one's the first one?
The pre-image.
The pre-image, are you sure?
Pre.
It's pre. It's before the transformation. Pre-transformation. This is shape number 1. So if that's the pre-image, that's number 1. What's the new one? The image is the new one. This is number 2. So how do I get from shape 1 and make it appear to be shape 2? Either I have to do every single point, or can I just pick one? You can just pick one. Because all these transformations are rigid congruence transformations. So I can pick one. I like A. So I need to count. Which way do you want to count first? You have to count over first. 1, 2, 3, 4, 5, 6, 7, 8, 9. Am I lined up with A right now? If I count 9 over. So I went right 9. Now I have to count from here. How do I get to the other A? How many is that? 1, 2, 3, 4. So I went right 9 and up 4. That's the rule to get there. Now I have to write it in geometric notation. Let's write it in vector notation. What am I doing? Oh, I forgot something.
Teacher.
The T, because I'm translating. Big T, translated. Okay, what number goes first? 9 plus 9. That's 9 to the right. How far up did I go? Plus 4. So that literally says move right 9 and move up 4. That's how I get from A to A prime. You see a little apostrophe there? That means prime. So is it tractor trailer prime or is it Optimus Prime? It's Optimus Prime, right? The big robot that saves everybody. So after you're a tractor trailer, you transform into a robot and you become Optimus Prime. That's why all these have primes. That's the after the transformation. So how does Optimus Prime go back to being a big truck? Okay, so I heard 4 down and 9 which way? 9 left. So let's take Optimus Prime and make him a truck again. What's the rule? -9. That's 9 to the left first, and then -4. Do you see any sort of relationship between these two? They're just opposites. So to go from the pre-image to the image, and the image back to the pre-image, those are just the opposite moves. All right? I'm going to skip this one because I really don't like it. So can we move on? All right. Now we're gonna translate. All right. You have a shape. I want you to follow the dance moves. So we have a triangle there. I need to move it -2, -3. So tell me the dance moves. Which way am I going?
Left 2.
Left 2. What does -3 mean?
Down.
Down 3. Left 2, down 3. That's it? Perfect. So I have to do that for every single corner of the triangle. So pick a corner, left, right, or bottom. Okay, it was a tough decision. We chose bottom. So I take this point and I follow the directions. Left 2, 1, 2, down 3, 1, 2, 3. Here's my new point. If I call this point A, this is now point A prime. 1 of the 3 is done. Is counting too hard for you guys? I don't know. I'm asking, it's a legit question. Are you okay counting? Because the only way to reflect is to count. Otherwise, you have to remember xy maps to negative xy, or xy maps to x comma negative y, or xy maps to yx. Lost you there, right? Or you can count. Here we go. So let's move point B. Translate it. It goes how many to the left and how many down?
2 to the left, 3 down.
1, 2, 1, 2, 3. This is now B prime. Let's move point C. Left 2, down 3. And we'll draw our new shape. A to B, B to C prime, C prime to A prime. Do the black triangle and the yellow triangle look like exact duplicates of each other? One is just a little bit lower, one's a little more to the left. Okay, what color is the image? Yellow. The image is yellow. What color is the pre-image? Black. Is this more fun or less fun than yesterday? Okay, is it more difficult or less difficult than yesterday? Okay, you may not have a fun meter, but you have a easy, medium, hard meter. Let's try it again. -1, 3, we're going to translate. So, what does -1 mean? Ooh. Left 1. What does 3 mean? Up 3. So take each of those points and move them left 1 and up 3. And I gave you guys super tiny graphs, so it was really easy to graph them, right? This is one of 6 different transformations we're going to do. Number 1, we're just sliding it. You feel good about sliding? There's reflections, there's rotations, there's glide reflections. All right. Use the rule to find the vertices of the image. So this one says T 2, -3. So what are they asking us to do if there's a T there? Translate it. Translate it. So I need to go 2 to the right and 3 down. So because this one is labeled with M, N, and O, I must relabel my new shape with M prime, N prime, and O prime. So translate your shape. It goes 2 to the right and 3 down. This is now M prime. 2 to the right and 3 down. This is now N prime. 2 to the right and 3 down. This is now Optimus prime. And we draw our new shape. Do the black triangle and red triangle look the same size? Easy, easy, easy. This is probably one of the least difficult things you guys will do this semester. Hopefully you're finding the simplicity in it. Yes or no? You okay? Wake up, 5th period. You can do it. Last one here. It just says write the rule. So I have to figure out which one is the pre-image and which one is the image. What's the OG original shape and what's the new shape? This one is the old one or the new one? This one's the new one because it has B prime, C prime, A prime, and D prime. So this is shape number 2. This was the original shape, shape number 1. So I have to figure out what is the translation rule I used to get from shape 1 to shape 2. Let's try it. Let's see if he's right. Did you count from A, B, or C, or D? Doesn't matter. B. You did B. 1, 2, 3, 4, 5, 6, 7, 8. Perfect. It is 8 to the left. And I'm hoping we get 7 here. 1, 2, 3, 4, 5, 6, 7. Perfect. The translation rule is T, -8, -7. Awesome, right? Guys, look, if you're comfortable with translations, reflections are just as easy because we're still counting. Honestly. So we're going to jump right into reflections. So take those notes and stash them where you stash them. We're going to wind up right here with reflections. Take a guess here. What do you think reflections do? They flip things. You see how that says reflections and it's been reflected? Now this is literally a question on your test. Is this the line of reflection? Is that the mirror, that red line right there? No, it doesn't make sense, does it? Is that the line between the two shapes? Okay, what about like this? More straight? No? What about like this?
Yes.
So you literally have to draw the mirror as part of your assignment. That's the mirror right there, right? It's been reflected across the yellow line. So when we do reflections, there is a mathematical way to do it. There it is. Yay, math. It says, if you want to reflect over the x-axis, this is the x-axis. You must use the rule, xy becomes x comma negative y. Remember that. If you want to reflect over the y-axis, xy becomes negative xy. And if you want to reflect over the line y equals x, xy becomes yx. Guys, this is the only one I need you to remember. Because you can't count that one. Okay? And here's what it looks like. If you're going to reflect across the line y equals x, just switch them. Okay? So the biggest and most oftenly missed concept here is you flip over the wrong line. Okay, you flip over the wrong line. So let's give a point. How about this point right here? A. Let's reflect that point across the x-axis. Do you think that's going to go from here down here, or that's going to go from here over here? Is it going to go up and down, or is it going to go left and right? Where's the x-axis? Right here. See it? X. That's my mirror. So to reflect, it's pretty complicated. Go from your point and count to the mirror. 1. And repeat. 1. This is A prime. It's been reflected over the x-axis. So if I asked you to reflect over the y-axis, which one's the y-axis? So you go from your point and you count to the mirror. 1, 2. and repeat. 1, 2. A double prime. I already have A prime. This is the second transformation, double prime. And the weirdest one is reflecting across that diagonal line, y equals x. So if I want to reflect this point over that line, that's a little harder to see, isn't it? So you have to know where the point is. The point is at -2, 1. So to reflect it, you just flip them. You just switch the points. So now if I plot the point 1, -2, A triple prime. That's the reflection. Okay, so reflection is all about counting. It's all about knowing where the mirror is. Okay? Let's try it. I think you guys are going to be excited to do this. Oops. Who wants to try and read that?
Reflection.
Okay, so what does the R stand for?
Reflection.
Reflect. What is this?
X-axis.
That's the mirror. Reflect over the x-axis. And what are we reflecting over the x-axis? A. So I need to take A. I need to reflect A over the x-axis. Is that this line? Or is it this one? So it's this line right here.
It's where C is.
Okay, so if I start here and I go 1, 2, repeat, 1, 2. Yes, that's where C is, but now it's also where A prime is. So A prime and C are in the same location. And I want you to know, what are the coordinates of the image? Where is A prime? What are its coordinates?
2.
2, -2. Alright, let's change colors and do another one. What does the R mean?
Reflection.
Reflect. What line am I? Oh, number 2. Reflect. What is this?
Y-axis.
The y-axis. That's this one right here. And what point am I reflecting? B. So go to B in blue and reflect it across this line right here. So go from your point and count to the mirror. 1, 2, 3, 4, and repeat. 1, 2, 3, 4. This is B prime. Where is B prime? Which one do you like better, reflections or sliding? They're both okay. If you had to pick, like life or death, flip or slide, what would you pick? You like sliding better? Is anybody a flip person? Alright, this one's weird. Look at this one. We're going to do this in purple. Reflect. Uh-oh. Y equals 1.
Oh, but the Y is where 1 is.
Okay, so Y equals 1. Is that right there?
Yeah.
No, it's not. That's X equals 1.
Flip it.
So if I go over 0, up 1, does Y equal 1 right here? So the whole line, that's where Y equals 1. It moves it up 1. So how can you cheat on this? If you go to your calculator and you go to the graph and you put Y equals 1, it will show you a horizontal line like this. Or if you go to your calculator and you put X equals 3, it'll show you a vertical line like this. So you can always check and make sure you have the right mirror. So I'm reflecting C, that's this point right here, over the purple line. So now it's not an axis, it's a line. It's the same concept. Start here and count towards your mirror. 1, 2, 3. Repeat. 1, 2, 3. So C prime is way up there. From the point to the mirror and past the mirror. So where is C prime?
2, 4.
2, 4. All right, my last one says a reflection across the line x equals -1. So start here. How do I go -1 in the x direction? 1 to the left. So I need to reflect across that orange line right there. So I'm reflecting point D across this line. 1. 1. So point D or point D prime is at 0, 2. Cool, right? Guys, reflections are not that bad. Are they fun for you?
Yes.
Totally, bro. Alright, so we have points here. We have points 3, 3, 5, 2, and 4, 4. The extra layer of difficulty now. You have to plot the points yourself. It can be easy and it can be difficult. So plot and label your points. 3, 3. 3 to the right, 3 up. This is point M. Five to the right, 2 up. This is point N. 4 to the right, 4 up. This is point O. Look at that triangle, Mon. How are we going to reflect it? Is that going to reflect up and down, or is that going to reflect left and right? Left and right. The y-axis is right here. Now, unfortunately, I have to reflect the entire triangle, not just one point, but all 3 of them. So you pick a point. I'm going to start with O. Count from O to the mirror. 1, 2, 3, 4. Repeat. 1, 2, 3, 4. This is O prime. Pick another point. M. 1, 2, 3. Repeat. 1, 2, 3. This is M prime. Pick the last point. Count to the mirror. 1, 2, 3, 4, 5. Repeat. 1, 2, 3, 4, 5. That's N prime. So when I draw my triangle, I get M prime, N prime, O prime. Do you see how it's actually reflected now? They are mirror images of each other. Baker, it's so cool. So the next question is going to ask you to replot the same points, but now flip the pre-image over the x-axis. We already have it drawn, right? Hopefully. Let's just go ahead and flip this triangle over the x-axis now. So where are we gonna count? Up and down or left and right?
Up and
Now it's gonna go up and down. So pick a point. 1, 2, 3. Repeat. 1, 2, 3. So now this is M double prime. Pick another point like O. 1, 2, 3, 4. Repeat. 1, 2, 3, 4. This is O double prime. 1, 2. 1, 2. This is N double prime. Prime time math all day. It makes like a little weird face. Like most of you guys drooling out of the corner of your mouths. Who's got jokes? They're still not funny. So I want you guys to watch this real quick. We haven't had this happen yet. So you see that arrow? What if I was going to reflect that arrow across the y-axis? What if I was going to reflect this arrow across the y-axis? You see why that might be troublesome? So I have to reflect it inside of itself. So in this situation, if I pick this point, which direction do I count to the mirror? To the right. So I count 1, 2, 1, 2. There's the arrow now. So now when I go to the other side of the arrow, 1, 2, 1, 2. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 1, 2. So now my arrow looks like this. You see how it overlaps itself? That can't happen. You can reflect something across itself. My favorite reflection is when something is on an axis and it asks you to flip it down. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 1, 2. 1, 2, 1, 2. How do I do this one? 0. Repeat. 0. And you leave it there. Look at all those arrows. Which path will you choose? Nobody? So this will be for you guys can look at this. It says there's a line of reflection. Can you redraw it after it's reflected? There's also stuff that looks like this. It says draw the mirror. Here's the mirror. Draw it for yourself. I don't think that's terribly complicated. We already kind of covered that. The last one is this. It says it's a double reflection. Right? It's like that super Snapchat filter where you got like 3 chins and your double reflection. So you have to do them in order. It says line 1, line 2. Now luckily we have 1 point. Z is right here at 1, 1. I want to reflect it across x equals -1 first. So how do I go -1 in the x direction? Left. So I want to reflect it across this line first. 1, 2, 1, 2. Z prime. Then it says reflect across the line y equals -3. So how do I go -3 in the y direction? Is that up, down, left, or right? Uh-oh. 1, 2, 3, 4. 1, 2, 3, 4. So somewhere down here. Z double prime. Okay? That's called a double reflection. We might get really crazy and do slide, then reflect. Uh-oh. Can you handle that? But that's not today. Today I'm just giving you baby steps. Slide it. Reflect it. Slide it. Reflect it. Okay? So what's going to happen tomorrow is you guys are going to get a couple questions that are going to ask you to tell me if this shape is a square, is a rectangle, is a rhombus. That's their mathy math day. On Friday, you'll get 2 papers. One's a couple slides. The other paper is a couple reflects, and that's it. So I'm going to ask that you guys work on 7-1 tomorrow. It's like 6 questions. You'll have the whole period to work on it. You'll turn that in tomorrow. On Friday, you'll get 2 papers. It's like 5 or 6 flip questions, and it's like 5 or 6 slide questions, and you'll have to turn those in on Friday. That's pretty much it. Okay? If you got lost or you fell asleep, remember it will be on the YouTube.